Hello everyone, I'm Said and welcome back. In this video, we're gonna learn the inverse trigonometric integrals from Calculus 1. The two most important formulas are the integral of 1 over the square root of a squared minus x squared dx equals arcsin of x over a plus c, and the integral of 1 over a squared plus x squared dx equals 1 over a arctangent of x over a plus c. These are the main inverse trig integrals you should know in Calculus 1. For example, the integral of 1 over the square root of 1 minus x squared dx. So if you look at this formula, a equals 1, right? So we have arcsin of x over 1 or arcsin of x plus c, or the integral of 1 over the square root of 4 minus x squared dx equals, we can write the integral of 1 over the square root of 2 squared minus x squared dx. So a equals 2, right? So we have arcsin of x over 2 plus c. And the integral of 1 over a squared plus x squared dx equals 1 over a arctangent of x over a plus c. For example, the integral of 1 over 1 plus x squared dx equals, in this problem, a equals 1, right? So we have 1 over 1 arctangent of x over 1 plus c, or the integral of 1 over 2 plus x squared equals the integral of 1 over, we can write the square root of 2 squared plus x, because the square root of 2 squared equals 2. Basically, we want to fit this into our main formula. So we have dx equals, so according to this formula, we have 1 over the square root of 2 arctangent of x over the square root of 2. So we have 1 over the square root of 2 arctangent of x over the square root of 2 plus c, right? Or the integral of 1 over 9 plus x squared dx equals the integral of 1 over 9 equals 3 squared plus x squared dx. So a equals 3. So 1 over 3 arctangent of x over 3 plus c. For example, the integral of 4 over the square root of 16 minus x squared dx equals 4 times the integral of 1 over the square root of 16 minus x squared dx. So this matches the general arcsin formula, because the integral of 1 over the square root of a squared minus x squared dx equals arcsin of x over a plus c. So in this problem, 16 is a squared, right? So a equals 4. So we have 4 times the integral of 1 over the square root of 16 minus x squared dx according to this formula equals arcsin of x over 4 plus c, and of course times 4 equals 4 arcsin of x over 4 plus c. the integral of 6 over x squared plus 36 dx equals, let's rewrite it as 6 times the integral of 1 over x squared plus 36 is 6 squared dx, right? So a equals 6. Now we use the general arctangent formula, means the integral of 1 over a squared plus x squared dx equals 1 over a arctangent of x over a plus c, right? So we have equals 1 over a is 6 arctangent of x over 6 plus c, right? And we have 6. So this expression times 6, right? So final answer is arctangent of x over 6 plus c. You might ask, what about arc cosine or, for example, arc cotangent? Well, we don't really need them. We can express all these integrals using just arcsine and arctangent. And don't worry guys, this topic is little challenging at first. In the next video, I'll work through more examples with you so you can understand it fully. See you next video.